We're going deep on some pretty cool research. It's about microalgae that are photosynthesizing under the Arctic ice during the polar night.
Photosynthesizing in near darkness.
Yeah, exactly. It's kind of mind-blowing, right?
It really challenges, what we thought we knew about life in extreme environments.
Yeah, it makes sense though, right? Like the Arctic polar night, it's totally dark, freezing cold. The sun's basically gone for months. So most things would just shut down.
Yeah, that was the traditional view for a long time.
Right. So how did this research even start? Like what made them think to look for this in the first place?
Well, there was this team of researchers, including a biogeochemist named Clara Hopp, and they were curious about what's happening under the ice when it's dark. Like they knew things had to be surviving somehow.
But not necessarily photosynthesizing, right?
Yeah, that was the surprise.
So how do they measure the light down there? I mean, it can't
Yeah.
be easy,
Right. It's not like you can just, drop a light meter in the ocean.
especially with all that ice.
Exactly.
Yeah.
So they had to get creative. A sea ice physicist, Niels Fuchs, and his team, they came up with this method to freeze light sensors right into the underside of the ice.
Wow, so they could capture those super faint light levels without messing everything up.
Oh!
That's awesome. What did they find out?
Well, for months, it was pretty much totally dark as you'd expect. But then in late March, when the sun briefly popped up over the horizon,
Oh, so there was a little bit of light.
yeah, a tiny glimmer. It was about 0.04 micromoles of photons per square meter per second.
Okay, I'm not really sure what that means.
Think of it like this. It's like a single drop of water compared to like a whole gallon jug.
Oh, wow. So barely any light at all.
Exactly.
But it was enough.
To trigger photosynthesis.
Yep. Hopp's team saw a spike in carbon uptake by the microalgae, and they also saw more chlorophyll, the pigment that makes plants green.
Right, that's how they capture the light energy.
Exactly.
Okay, so they're photosynthesizing with almost no light. But what about those other months when it's completely dark? How do they survive? That's the big question. And scientists are still figuring it out. The research suggests a few possibilities.
Like what?
Well, they might be eating dissolved organic matter in the water, basically scavenging for nutrients.
Right.
Another idea is that they might be using bioluminescence from other organisms.
So like harnessing the light from those deep sea creatures that glow.
Yeah, exactly.
Well, it's like they've developed these amazing survival strategies to deal with that darkness. But they're not totally dormant during those dark periods, right?
Right, they're not just sleeping. They maintain a low level of activity. It's almost like they're in standby mode.
Ready to spring into action.
The researchers call it a ready-to-go state.
Oh, I like that.
Yeah, think of it like a seed bed, just waiting for the right conditions to sprout.
So they can jump right in as soon as there's a little light.
Exactly. It gives them a real advantage in that extreme environment.
This ready-to-go thing is pretty wild. What does all this mean for the whole Arctic ecosystem? Does it change how we think about things?
Absolutely. It challenges that traditional view of the Arctic as a boom or bust cycle.
So not just a big burst of activity in the summer and then hibernation all winter.
Right. It suggests that there's a lot more happening under the ice than we realize.
So instead of a seasonal vacation spot, it's more like a year-round bustling city down there.
Pretty much. And, this discovery has actually sparked some debate in the scientific community.
Oh, really?
Yeah. Some researchers, like Kevin Flynn, they're not so sure about whether the microalgae are actually photosynthesizing during that late March growth spurt.
What do they think is happening?
They think it might be more of a preparation phase. They're building up chlorophyll to get ready for when the real light show begins.
So kind of like stocking up on supplies before the big rush?
Yeah, exactly.
Interesting.
Yeah.
But we also talked about Douglas Campbell, and he has a different take on things.
Right. He thinks photosynthesis might actually be happening even earlier than the research shows.
Wow. Pushing the limits even further?
Exactly.
This is so fascinating. There's clearly a lot more to learn about these tough little algae. But unfortunately, we're out of time for now. We'll be back soon to explore more of these implications and dive deeper into this scientific debate. Stay tuned. So we're back and ready to keep diving into this amazing world of Arctic algae photosynthesizing in near darkness.
They really are incredible little organisms.
Yeah, we're talking about how this could impact the whole Arctic ecosystem before the break. Like, how does this year-round primary production affect the food web?
Well, it's like this. Traditionally, we thought of the Arctic food web as being super seasonal.
Right, phytoplankton bloom in the summer when there's sunlight, and then everything else feeds on that.
Exactly. But if these microalgae are active all year round, it means there's a more constant flow of energy through the ecosystem.
So instead of a feast or famine situation, it's more like a slow and steady supply of nutrients.
Exactly. And that could have a big impact on things like zooplankton
Oh,
blooms.
yeah, because they usually depend on those phytoplankton.
Right. They might start blooming earlier, or there could be multiple smaller blooms throughout the year.
And then that would affect the bigger animals too, right? Like the whales that rely on those zooplankton.
Exactly. It's like a domino effect. The activity of those tiny algae can influence the whole food web.
It's amazing how connected everything is. And it makes you think about the implications for climate change too.
That's a really important point. We know that phytoplankton play a big role in absorbing carbon dioxide from the atmosphere.
Right.
So if these Arctic algae are more productive than we thought, they might be absorbing more carbon dioxide than we've accounted for.
So that's good news, right? They could be helping to fight climate change.
It's possible, but it's not that simple. We need to consider other factors too, like how changing ice conditions might affect these algae populations.
And how more food might change the carbon footprint of the larger animals.
Exactly. It's a complex system with a lot of moving parts, but this research gives us a new piece of the puzzle.
It's definitely changing how we view the Arctic ecosystem. So we were talking about the debate over whether the microalgae are actually photosynthesizing during that late March growth spurt.
Right.
Can you remind us of Kevin Flynn's argument again?
Sure. So Flynn's point is that just because there's chlorophyll doesn't necessarily mean there's active photosynthesis happening.
Okay.
It's possible that the microalgae are using stored organic matter from the summer months to produce chlorophyll. And they're
Yeah.
doing that to get ready for when the sun comes back.
So like they're getting a head start on the competition.
Exactly.
But then we have Douglas Campbell, who thinks photosynthesis might be happening even earlier.
Right. Campbell argues that the theoretical minimum for photosynthesis is just that, a minimum.
Meaning organisms could actually be doing it at even lower light levels.
Exactly. Maybe these microalgae have found even more efficient ways to capture and use light energy.
That's amazing to think about.
Yeah.
And if that's true, it could change how we understand the limits of life, not just in the Arctic, but everywhere.
Right. It could mean that life exists in even more extreme environments than we thought possible.
This is blowing my mind.
Yeah.
So shifting back to the Arctic, what are the big picture implications of all this?
Well, if you step back and look at the whole thing, this research paints a much more dynamic and resilient picture of the Arctic ecosystem.
It's not just a passive system that shuts down in the winter.
Right. It's a web of life that keeps going, adapts, and even thrives in near darkness.
That's incredible. It shows just how powerful evolution is.
Exactly. And as we keep learning about the Arctic and climate change, this research is really important. It'll help us understand what's happening and protect this fragile ecosystem.
This has been a truly fascinating deep dive into the world of Arctic algae, but unfortunately we're out of time for this segment. We'll be back soon to wrap up our discussion and leave you with some thought-provoking questions to ponder. Stay tuned. And we're back for the final part of our deep dive into these amazing Arctic algae that can photosynthesize in almost total darkness.
It really makes you wonder what other secrets are hidden in the depths of our oceans.
Yeah, and as we've seen, this discovery isn't just a cool scientific fact. It has some big implications for the whole Arctic ecosystem.
Definitely. Like we talked about the potential changes to the food web, the migration patterns, and maybe even a role in fighting climate change.
It's crazy how interconnected everything is, and how much we still don't know about these seemingly remote places.
It shows us that what happens in the Arctic doesn't stay in the Arctic. It affects the whole planet.
So true. So let's go back to that debate about the timing of photosynthesis in these microalgae. Have Kevin Flynn, who's skeptical about full-blown photosynthesis in that late March growth spurt. And then Douglas Campbell, who thinks it might be happening even earlier.
Right. Flynn is being cautious and reminding us that just because there's chlorophyll doesn't mean there's active photosynthesis going on.
Right.
He thinks the microalgae might be using stored energy to make chlorophyll as a way to prepare for when the sun comes back.
Okay, so like a strategy to get ahead of the game.
Exactly. But then you have Campbell, who thinks photosynthesis might be happening even earlier than we can measure.
Pushing the boundaries even further.
Yeah, he's suggesting that maybe we haven't found the true lower limit of photosynthesis yet. Maybe these algae are even more efficient than we thought.
That's wild. What kind of research would you like to see done to figure this out?
I'd love to see studies that track the algae throughout the whole polar night, not just in March.
To see what they're doing in those darkest months.
Exactly. We need more data to understand how they get their energy, what their metabolism is like, and how they stay in that ready-to-go state for so long.
And what about their genes? Like, what makes them so good at surviving in low light?
Yeah, comparing them to other algae that live in darkness, like in the deep sea, that could tell us a lot about how they evolved.
This research has really opened up so many questions. Feels like we're just getting started.
Definitely, this is just the beginning of a much bigger story. And as we explore these dark corners of our planet, I think we're going to find even more amazing things. Things that challenge our assumptions and show us just how incredible life on Earth really is.
That's a great way to put it. And for our listeners who want to learn more, be sure to check out the links in the show notes. We've got the original research paper plus other resources about photosynthesis and life in extreme environments.
Keep asking questions, keep exploring, and be open to the unexpected.
Couldn't have said it better myself. Thanks for joining us on this deep dive into the world of Arctic algae and their amazing ability to thrive at the edge of darkness. Until next time, keep exploring.